So let's take a look at the angle bisector theorem and the converse. So the angle bisector theorem states that if a point is on the bisector of an angle, so in this case, point D is on the bisector of an angle, and we could see here because AD actually cuts angle BAC in half. And so D is on the bisector of the angle. Then the point is equidistant or the same distance from the sides of the angle. So if AD bisects angle BAC, this is angle BAC right here, that large angle BAC. AB is perpendicular to BD. So AB right here is perpendicular to BD here. And we have our right angles here to show that they're perpendicular. And AC and CD are perpendicular, so we have our right angles here. Then we can conclude that BD is congruent to DC. So that would make these two lines congruent. So that is the angle bisector theorem. So basically, if you have an angle bisector and it cuts a larger angle in half, then it makes two, then that interior angle would be equidistant, or the interior point would be equidistant from the endpoints right here. All right. And then we have the converse. So it says if a point is on the interior of an angle and equidistant from the sides. So again, we're talking about point D, and we see it is equidistant because we have these congruent marks. Then the point is on the angle bisector. So we can conclude that if BD is equal to CD, and AB and BD are perpendicular, and AC and CD are perpendicular, then AD bisects, I'm sorry, this is AD, bisects angle BAC. So if it bisects it, it means it cuts it in half, so that would make these two angles congruent. So that would mean the measure of angle BAD is equal to the measure of angle CAD. So that is the converse of the angle bisector theorem. All right, so in this problem, we want to find AD. So the length of this side right here, AD. So we can use our knowledge of the angle bisector theorem. We know that BD is an angle bisector because these two angles here, angle CBD and ABD are congruent. So BD would be an angle bisector. Then the point is equidistant from the sides of the angle. So if D is equidistant from the sides of angle BAC, that would make AD and DC congruent or equal. And let me just put one congruence mark here. That will make AD congruent to DC. Now to find AD, I have to find X first. And since according to the angle bisector theorem, we can conclude that AD is congruent to DC, we could simply set these two expressions equal to each other and solve for X. Subtracting 8X using inverse operations in our algebra skills. And adding 4, left with that two-step equation. 5x equals 15, dividing by 5, x equals 3. All right, so we found x. We want to find AD, so we simply take 13 x minus 4 and plug in x. So 13x minus 4, that is AD. So 13 times 3 minus 4, 39 minus 4. So AD would be 35. All right, AD is 35. So we found the answer, but let's double check. Since we know that AD, all right, and DC are congruent, when we plug in 3 for x here, what should we get? We should get 35 because they are equal lengths. So let's double check it. So 8 times 3 plus 11, that would give me 24 plus 11, and that does in fact give me 35. So always double check your work. If these lines are congruent, we should get the same answer, and we do. But in this case, we only had to find AD, and AD is in fact 35. All right, so in this last problem, we're asked to find the measure of angle XWZ. So XWZ would be this angle right here, XWZ. All right, so half of the larger angle XWY, we only want this portion here. So we can use the converse of the angle bisector theorem. It says if a point is on the interior of an angle, so we could say Z is on the interior of the large angle XWY, and it is equidistant from the sides of the angle, and we see here that Z is equidistant from the sides X and Y because we have these congruence marks, then the point is on the angle bisector. So we can conclude that WZ is an angle bisector. All right, so since WZ is an angle bisector, that would mean that these two angles, XWZ or ZWX and YWZ, are congruent. So these two angles right here would be congruent, right here and here. So since they are congruent, to find X, once again, we could simply set the two expressions equal, because angle XWZ is 8x minus 32, and angle YWZ is 3x plus 3. So each angle, since Z is on the angle bisector, they are congruent. And so we can just solve for X by doing inverse operations, subtracting 3x, 5x minus 32 equals 3, adding 32, 5x equals 35, dividing by 5. So x is 7. We're not done because we're asked to find the measure of angle XWZ. So XWZ again would be this angle here. So we just plug in our value. 8 times 7 minus 32. So 8 times 7 is 56 minus 32. That gives me 24. So this angle would be 24 degrees. Now what should angle YWZ be? All right, if they are equal angles, it should also be 24. So let's check it. I'm going to plug in X for the 3x plus 3. Let's plug it in. 3 times 5 plus, 3 times 7, not 5. 3 times 7 plus 3, 21 plus 3, and that in fact gives me 24. So just double checking, they should be congruent. So we're asked to find the measure of angle XWZ. That of course is 24. So we've used our knowledge of the converse of the angle bisector theorem and the angle bisector theorem to solve these two problems. Okay, so we've reached the end of our lesson. Thank you for learning with me. Some related videos are mid-segments of triangles and perpendicular bisectors of triangles. Also, please like, comment, and share. And if you haven't already, subscribe. And once again, thank you for learning with me.